So this is question 20 of the 2020 external exam, the first paper, Tech Free. I think it's arguably the hardest question in terms of not like other questions. I think the question prior to this is harder in terms of mistake making, like very easy to make mistakes. But this question's probably the hardest in terms of how you solve it, I'd say. So this is just my approach. There are probably different approaches, and the marking guide may have a different approach, but this is, yeah, just a work solution. So at the end of the first stage of its growth cycle, a species of tree has a height of 5 meters and a trunk radius of 15 centimeters. In the second stage of its growth cycle, the tree stays at this height for the next 10 years. However, in the growth rate of the trunk radius in centimeters per year varies over the 10 years and is given by the function. So this is your rate. The growth rate of the trunk radius. Assume the density, mass per unit volume, of the tree trunk is approximately 1 gram per centimeters cubed, and the tree trunk is the shape of a cylinder. Determine the ratio of the trunk's mass at the end of the second stage to its mass at the end of the first stage. Okay, so there's a lot here. First thing you should do is, because it speaks about mass, but it also speaks about centimeters per year. Centimeters is not mass, it's a unit of measurement. And years, it's time. So you should really consider the units in this question a lot, because you aren't starting where you aren't finishing where you start, if that makes sense. So I would recommend that you write centimeters per year, and you need to consider this because you're probably going to be using unit conversion a lot. So to start, because it's also important to consider this first part. At the end of the first stage of its growth cycle, a species of tree has a height of 5 meters and a trunk radius of 15. In the second stage, so you can assume that the second stage pretty much starts the moment the first stage ends. That's also something to consider. And you need to know your density, but this will come in handy near the end where you determine the mass. So, determine the ratio of the trunk's mass at the end of the second stage to its mass at the end of the first stage. So because this is a rate, and you don't really want to be using your rate, you're probably going to have to integrate this. So this is your rate. Let's just call it let's just call it capital R. So capital R of t. Actually, I should use black pen. Capital R of t. So let's just find the marginal growth rate, or just the growth, pretty much at each point, because we have the rate here currently. So RT is going to be equal to the integral of log RT dt, which is going to be equal to the integral of 1.5 plus sine of pi t over 5 dt. Now it's important to consider that because this is a tech-free question, you don't want to really be using decimals as much as possible. You kind of want to avoid them to the best of your ability. So I'm just going to consider this as 3 over 2. Because 1.5 is equal to 3 over 2, so I'm kind of just going to consider this 3 over 2 for the rest of the question. So I won't rewrite that though, so I'm just going to take the integral of this. So the integral of this is going to be, and this is also a definite integral, an indefinite integral. This is not a definite integral because we don't have parameters. We don't need parameters for the minute. So this is just going to equal, so 3 over 2 t plus, now you know the integral of sine. If we draw the sequence, if we just draw this, this is how I remember it really. So, you can kind of remember it like this. So when you integrate, you go backwards. So when you integrate sine, it will turn to negative cos. So plus, let's just put this in brackets because we've already taken the plus. So negative cos pi t over 5. And when you integrate a trig function, the inside function must divide. So let's just divide that here by pi t over 5. It would just be pi over 5, not the t. and then plus c. Let's simplify this. So 3 over 2t minus, and when you divide by a fraction, you can multiply it by the inverse. So 5 over pi cos pi t over 5 plus c. So this is going to be your integrated function here. So it doesn't really give us any, so we obviously need to find c, otherwise the function won't be complete. So to do that, this is where we need to consider that at the end of the first stage. So this pretty much means, because at the end of the, because if you go to the first stage into the second stage, at the end of the first stage is pretty much equal to the start of the second stage, because there's no real gap between. So it's right here. So we can pretty much consider that these measurements here, so a height of 5 meters and a trunk radius of 15 centimeters, so this is pretty much saying the moment the new cycle starts, because we're using the new cycle in this r of t, because this is what it's given to us, this is of the second cycle, this function. So you can assume that at t equals 0, because this is when it initially starts, when time equals 0, your radius is going to be equal to the end of the previous, which is 15 centimeters. So let's consider that. Let's just put a little note from information provided, comma, r at time equals 0 is equal to, what was it? 15 centimeters. Now remember, it's going to be the radius, because that's what we're working with here, the radius. And even though you've integrated, you're still using radius. And make sure it's in centimeters. So this is given in 15 centimeters. I'm going to erase that a bit so it's more visible, this underline. But 15 centimeters is pretty much what we're using. You need to remember that your unit should stay constant throughout, otherwise you'll get an incorrect answer, because they could easily give this as 15 meters, or something similar, and it was 0.15 meters, something like this, and it would trick you. You would expect that in a really hard question. So from information provided, r of 0 is equal to 15 centimeters. So considering that, I don't know why my pen's doing that. So r of 0 equals 15. So it means 15 is going to be equal to this function, with t equal to 0. So 3 over 2, 0, minus 5 over pi, cos pi 0 over 5. Remember that 0 is going to cancel everything in here and make it equal to 0. Plus c. So now you know that this is going to cancel, and everything in here is going to cancel because 0 is involved. So 15 equals 0, so I'll just ignore that, negative 5 over pi, cos of 0 plus c. Now, if you use your unit circle, or use memory, or I believe you can use special triangles, but I just use your unit circle, you know this is the point 1, 0, at 0, and 2 pi. The coordinates are 1 and 0, and cos is your left point, which is going to be here, so cos of 0 is equal to 1. So 15 equals negative 5 over pi, 1 plus c. 15 equals negative 5 over pi plus c. Let's isolate c so we get an answer. So put this on this side, 15, and change the sign to a positive because it's a negative on this side. 5 over pi equals c. And I'm going to simplify this so it can all turn into one fraction. So it isn't two parts pretty much. And I'm going to put c on this side instead. So c is equal to 15 pi plus 5 on pi. So I just turn this into a fraction. So now to finish this page, I'm going to go, therefore, r of t is equal to, so I'm just going to take from up here and add the substitute c in, 3 over 2t minus 5 over pi cos of pi t on 5 plus 15, I'm just going over the page, you can't really do this in an exam, but I don't really care, over pi. So that's your function. Now, so in the second cycle, the tree stays at this height for the next 10 years. And the question asks, determine the ratios of the trunk's max at the end of the second stage. So because it says it goes for the next 10 years, you can assume that the end of the second stage is going to be at t equals 10, because this is a year. T is in years. If it... Does it say it in the question? It doesn't say it in the question, but something with... so when you are differentiating functions, because, for example, RT is going to be... the value for R is going to be in centimeters, right? But when you differentiate this, the unit for T, if you differentiate any function, the unit for T, or X, or the variable inside this, is going to be underneath, so the unit is going to change to this unit divided by, so the R unit divided by the T unit. So knowing that, because this is, you know that this is a differential of R of T, and if this is centimeters over year, you know that T is going to be in years, if that makes sense, because it doesn't, I don't know if it says it in the question, I can't read it currently, but yeah, it's a good thing to know. Yeah, it's how usually, that's the purpose of a rate. But now that you have this function, I'll continue it up here. So now we want to pretty much use this, because this is in centimeters, remember, so I'm just going to write centimeters down here. So we're going to use this to find not the mass, but the length, the radius of the tree trunk at the end of the second cycle. So let's continue over here. So RT, I'll write that all out again, 3 over 2, so it's just that I need to flick back and forwards, minus cos, what was the function? Minus cos, minus 5 over pi, cos pi t over 5, plus 15 pi plus 5 over pi. There we go. And then let's just put centimeters down here. So now, at the end, so let t equal 10 years to get the end of the second cycle. So R, 10, remember t is in years, so 3 over 2, 10, minus 5 over pi, cos pi 10 over 5. And you know that these, because this is 10 over 5, you're going to know that this is going to cancel and result in a 2 at the top, plus 15 pi plus 5 over pi. So now you can go equals 30 over 2, you know that's going to equal 15, because, yeah, 30 divided by 2 is 15, so 15 minus 5 over pi, cos, and now you know this is going to be 2 pi, because the 10 and the 5 cancel to give you a 2 on top, so 2 pi plus 15 pi plus 5 over pi. Now, so let's get rid of this cos first, so we know that using the unit circle, 2 pi is the same as 0, so as established before, this was the 0.10, so the cos is going to equal 1, so this is going to equal 15 minus 5 over pi, 1, plus 15 pi plus 5 over pi. 15. I'll zoom in a bit. So this equals 15 minus 5 over pi plus 15 pi plus 5 over pi. Let's simplify this. So we can actually do kind of this step again with this by turning this into one fraction. So it equals 15 pi minus 5 on pi plus 15 pi plus 5 on pi. Now, because these are the same denominators, we can combine these fractions. So 15 pi minus 5 plus 15 pi plus 5, all this over pi. And this is a plus 5 and this is a minus 5, so these can cancel. And these can add because it's 15 pi plus 15 pi. So you'll end up with, so 15 plus 15, 30 pi on pi. And because these cancel, these are ignored because they equal to 0. And then now these pi's can be cancelled and this equals 30. 30 centimeters. Now, now that we have this, so at the end of the first cycle, the radius is 30 centimeters. And, as this says, a species tree has a height of 5 meters and a trunk radius of 15. Now it says, in the second stage of the growth cycle, the tree stays at this height for the next 10 years. So it stays at the same height, so the height equals 5 meters as well. So now that we have this, we need to understand the density, which is, not the density, but the mass. And because we have the density formula, this contains the mass, but also contains centimeters cubed. Centimeters cubed is a unit of volume, so this is a unit of volume. You need to remember. And the volume of, so, the unit of, and the trunk radius of this, so the second side of this height for the next 10 years. So, you pretty much know that this is going to be a cylinder, because you have centimeters for a radius, so you have your radius of your tree trunk given to you, centimeters, and you also have the height of it. So you can kind of assume that this is a cylinder. So knowing that this is a cylinder, you need to know the volume for a cylinder. And the volume for a cylinder, because you know that a cylinder is pretty much a circle that has a depth, you can kind of just assume that the volume for a cylinder is going to be the area for a circle, so pi r squared, and then multiply that, because you know that this, and then multiply it by the height, times height. So volume of cylinder is going to equal h pi r squared. So now that you know this, you can come down here and go vol cylinder equals h pi r squared. So now let's figure out the volumes of the current tree that we're working with after the second cycle and the first one, because that's going to be the way that we find the mass, because the mass is going to be given through this density. It actually says here the tree trunk is in shape of the cylinder, so yeah, that's where that comes from. The tree trunk is approximately 1 gram per centimeter cubed. Now, no, yeah, so this is going to be how we find the mass. So we're going to have to pretty much find the volume, because this is a unit of volume, remember? And then convert that to mass, because we know the density. So volume of the cylinder equals pi, h pi on r squared. So now let's divide this into 2 sections. And do, let's call it V, so capital V, initial, so after the first cycle. So V initial, and then V final. So this is going to be after the second cycle. So initial is going to be first cycle, final is going to be second cycle. So for the initial, it tells us a height of 5 meters and a trunk radius of 15 centimeters. Now, this won't work out if we just do it like this, because height here is in meters and a trunk radius is in centimeters. You can't do calculations like this that contain different units, so you want to convert this to centimeters, but this is quite easy because 5 meters, so 1 meter is equal to 100 centimeters. So you can convert this. What I'll do is I'll do this off the side here. So your height of the initial, is equal to 5 meters, but using the unit conversion method, you can go 5 meters times, you put meters on the bottom, 1 meter on the bottom, times 100 centimeters. So it's 100 centimeters in a meter. So units will cancel, and you'll end up with 5 times 100, which is equal to 500 centimeters. And the reason we're converting to centimeters and not to meters, because we could easily convert the radius to meters, is because this is given in centimeters cubed. So we want to be using centimeters. So after we've done that, because remember, the height stays the same across both the cycles, it's only the radius that changes. So it's going to be, so V initial is going to be h, which is 500 centimeters. Let me fix that. So 500 times pi and then r squared. So the radius it gives us is 15 centimeters. 15 squared, and you know that the v final is going to be the same 500 pi, because height stays the same, remember, across both cycles. And then the new one after the second cycle, which is 30 centimeters. 30 squared. So let's continue this. 500 pi. So from this stage, because it's going to be a so actually let's just continue this. So you know the v initial is going to be 500 pi 15 squared, but 15 squared is equal to 225. I didn't use a calculator for that, I just remember it, but you can, so 15 times 15, so it's going to be 25, so you do your 5 here, 2 times 5, 1 times 5 is 5 plus 2, so 7 plus, and then 1 times 5, 5, 1 times 1, you have to put your 0 in here, and then 1 times 5 is going to be a 5, and then 1 times 1 is going to be 1, equals, 5, 2, and then 2, so 225, and 30 squared is 900, so it equals 500 pi times 900. 900 times 500 times 500 is the same as 9 times 5 times 1000. I mean 10,000, because you're carrying the zeros. So it's equal to 45. 45 times 10,000. It's going to equal to 450,000. So this is going to be 450,000 pi. And 500 times 225 is going to be 225 times 5 times 100, because you're carrying the zeros. So this is going to be 5 to, so 25, 2 here, so 12, and then 1 here, so, and then 11, 1125, and then add 2 zeros from multiplying it by that. So this is going to be equal to 112500 pi. And these are your volumes. So this is in centimeters cubed. But you also know that the density, if we erase these lines here, so density is in 1 gram per centimeter cubed. So you can actually, so if we're working with grams, it actually asks us for a ratio between the two, so it doesn't matter what we work in, but we're going to work in grams because that's what's given to us, even though grams isn't an SI unit. So let's get rid of this again, accidentally put it back. So it's going to be 112500 pi times, and the density to get the grams, so 1 gram per centimeter cubed. But you're pretty much just timesing it by 1, because this is in centimeters cubed here as well, it's carrying the units. And this is just going to cancel it, and just you're multiplying it by 1. So these, according to that, this is going to be this amount of grams, and then using the same, it's going to be 450,000 pi grams, because you're timesing them both by the density, but all it's doing is multiplying by 1, because your units cancel out nicely. And this is your V initial. And when you do ratios, it's usually done by final over initial. Yeah, at the end at the end of the second stage to the end of the first stage. So then the ratio, let's just call this ratio, is equal to, so 450,000 pi to 112,500 pi. And when you're working with ratios, you can make, so the ratio, if you want a single number for a ratio, you do this one divided by this one, so you'll do 450,000 pi divided by 112,500 pi. These cancel, so you end up with 450 over 1125, and this is equal to 4. So using this, the after divided by the initial is equal to 4, which pretty much means, so let's just comma, hence the mass of the, is it tree trunk? Yes, tree trunk has quadrupled between the end of both cycles. That's going to be your answer. I don't believe that you need to give a small conclusion, because it just asks for the ratio. It doesn't ask you to prove anything. Like, it doesn't ask you to, or it doesn't ask you to justify the answer and like show your understanding of what it means. But this is your answer. Thank you.